Welcome back. We're continuing on with Chapter 10. We've talked a little bit about residential WAN circuits, but now it's time to switch back to business class technology using a public switched data network, PSDN, as opposed to the PSTN, public switched telephone network. Typically this is also through a telco, and I mentioned what a point of presence in class and why it's important to know where your point of presence is. This is just showing you, so instead of drawing like routers and so forth that we're connecting to, there's just at the WAN level we can abstract a little more and just show the, this as lease line. I mean, technically this line right here would be an access line. Trunk lines in here, so to go from here to here is a leased line. From here to here is a leased line. From here to here is a leased line, and so forth. Like I said in class, where your POP is matters. So for example, this is a 2011 map, but just shows you points of presence. Again, it does illustrate how these points of presence are not spread out evenly throughout the U.S. I think this is a more recent view of just Charter and their legacy. So originally Charter plus all of their new acquisitions. Charter is huge in the Midwest. I mean, obviously huge here, and then not so much out here. I did find a map that's a little newer for Spectrum / Charter from 2018 that shows their points of presence in a little more detail. Again, notice the coverage in the Midwest. They're trying to expand more out west, but there's still whole swaths of areas where they have no coverage. Now, I'm sure they'll continue to acquire little cable companies here and there to expand their coverage, but it's important to see these cable companies as a patchwork of different, completely different in some cases, networks. Networks within networks within networks. These points of presence, if it helps you to think of it as using the metaphor of a train station, kind of where you change trains to go from one network to another network. A lot of these points of presence maps look kind of like an Amtrak map. Similarly, Amtrak does not go everywhere. You can only get on its system wherever they've got a train station, i.e. a point of presence, if you will. And then you can only go where they can connect you, which is not everywhere. So the analogy isn't a terrible one. This map, there's a whole story behind this map with some of my experiences working with Charter. This was back in North Carolina, but the short version is that I was able to find an exception to the rule where cable companies can't give you a good SLA. Because remember, we drew on the board how Charter doesn't control all these other ISPs, so how can they give you an SLA? They can't guarantee, start to finish that your packets are going to go through unless you sign a contract guaranteeing that all the traffic that you're sending between your locations, they're all going through a Charter point of presence and staying on Charter's network. Then you can get some killer pricing from them. So if all sites connect to a single ISP, the ISP can provide QoS guarantees. That's what I added to this slide, so not in the textbook. Just restating that, well, I guess one good thing this picture shows you is how one company might have a connection to the internet, a connection to another location using MPLS, which we'll talk about, and another connection to another site over the public switch data network. Most companies are hybrids, and they'll have multiple WAN circuits, not just one WAN circuit, multiple WAN circuits. All of these circuits, and in the previous example, they're all different types of lease lines. I do want to point out that we talked about the legal demarc. That legal demarc that separates, where your responsibility ends and the phone company's begins. It's not a hole in the ground. It's typically a little box called a CSU DSU. Sometimes it's called a smart jack, but here's what the box looks like. It's usually just a simple device that has kind of two green lights that you care about inside and outside to tell you whose problem it is. Okay, notice here that This almost illustrates a mesh network. If we had a line here, in fact from here to here, and from here to here, and there straight there. So right now this is, and if these lines weren't there, it'd be more like a star topology. So this is kind of a blended topology, halfway between mesh and star. Notice the thicker pipe for the OC3 here, because apparently they need a better, faster connection here, and not as fast a connection here. Again, no company really has one WAN circuit. They have multiple WAN circuits that are based on what? You got it. The business requirements. Good job. Also, when you're drawing a picture like this, and you just show, sorry about that, my phone rang. I think I was going to say that this picture illustrates, if you just show the buildings with lines between them, that's kind of an example of a logical diagram, whereas when you kind of zoom in and start showing the physical hardware that's connecting, this is more of a physical diagram instead of a logical diagram. Please note that you need a router at each location, so you're connecting different networks together. So WAN circuits, by definition, connect different networks to each other. And the only way you can connect different networks to each other is with a router. Please, please, please just know that. That's in that small list of things you need to retain with you once you leave college. Okay, routers are what connect different networks together. If you say anything else, that's going to be, you're not going to sound smart. And for the love of God, you can't plug a server into a router. You plug servers into switches. Okay. A little more on moving kind of past the actual hardware of the routers and CSU, DSUs and such. WAN circuits also have very specific protocols. Some are based on TCP/IP that are part of the OpenStack family. Some are not. Some are proprietary. There's a long list of WAN circuits. These are primarily layer 2 protocols. So on the LAN side, it's very easy. Layer 2, it's all about Ethernet. That's it. Outside on the WAN circuit, you could have any number of things, including a hybrid model where you've got multiple circuits running multiple protocols. Frame relay is what I'm used to, but that's on the way out. Frame relay is quickly getting replaced with Metro Ethernet and MPLS, for example. Frame relay was popular because it was very customizable in terms of the size of the frame relay circuit that you wanted. You can even slice up a T1 line into, I know you're going to laugh at seeing kilobits per second, but back in the day, that's what we needed to do. So you could use part of a T1, you could combine T1s together to bond them together in pretty much the same way that you can bond 2 network cards in a server to double your speed. Just FYI. There is just a 1 minute 45 second introduction on frame relay. It's part of CompTIA training. There's something similar in Test Out that they talk about. I just like a lot of Professor Messer's stuff. If you want to watch 2 minutes on frame relay, that's going to give you a good background. ATM in our world does not stand for automated teller machine. It stands for asynchronous. So sorry, I literally had to Google that to remember what it stands for. Asynchronous transfer mode. I would not ask you on the exam asynchronous transfer mode, just recognizing ATM as one of the layer 2 WAN protocols. Much more widely adopted in Europe, not so much in the US. You're hardly ever going to see this in the US. Metro Ethernet you're going to see a lot more of coming very soon. So 10 megabits per second up to a gigabit per second on the WAN side. Are you kidding me? That's astounding. Carrier Ethernet is another term for it. This is the only one that's really growing rapidly. But while Metro Ethernet works a lot like regular LAN Ethernet does, Ethernet is very inefficient. If you need a much more efficient protocol, MPLS is the answer in terms of being a super smart, optimized layer 2 protocol on the WAN side. And it solves a big problem, which is, remember how routers work. They go through 3 steps, they find all the possible matches, they determine the best match, and then they send it out the interface. That's a lot of processing that the router has to do for every inbound conversation. Whereas what if the router could kind of predetermine if something comes in on, from this IP address going here, let me just tag it very quickly because I already know the best route for that traffic, and send it on in without nearly as much processing. That's what multi-protocol label switching, MPLS, uses. I don't have any hands-on experience with MPLS. I do know that it's rapidly being implemented in the industry. It does require a more expensive, router that understands MPLS. So notice it's identifying the best route for a range of IP addresses before sending the data, kind of creating shortcuts, if you will. I do have some notes here on how MPLS works. Obviously, both ISPs have to have implemented MPLS in the same way, and it is considered a layer 2.5 protocol just because it can carry different protocols on top of it, which is a little weird. And I would say, rather than understanding how tagging works, which there's a video that explains tagging to you, on the business side of things, just understanding that MPLS reduces the cost of the forwarding decision that the router's making. Lets you do some traffic shaping, includes quality of service and load balancing, which other protocols don't necessarily give you. I mean, long term there are some cost savings because the router doesn't have to process as much. But I would say it's more expensive to implement, at least initially. It's a lot more expensive to implement. There is a good video on 6-minute video, especially the first minute I would watch, on how MPLS tagging works. Here's the thing though, this guy has a much thicker Southern accent than I do, so you might have to really listen closely to translate what he's saying, but he's a good source for kind of slightly more technical topics. As we wind down our final chapter on WAN circuits, I just want to point out that everything we've talked about and the textbook, the Panko textbook, talks about, these are all technologies, protocols, types of circuits and services that any WAN book is going to cover. If you look at any of Cisco's documentation on WAN circuits, they're going to look at exactly the same list of technologies that we've looked at in this chapter so far. Okay, time for the big finish. I promised you at the beginning of the chapter that we were going to answer the philosophical question of what's inside the cloud. Strictly speaking, I should be teaching cloud as just another example of outsourcing, and it is. Or if you want to think of clouds as somebody else's network, that's fine too. I think it's helpful to think of what's inside the cloud this way. Here's the philosophical answer to what's inside the cloud. Here it is. More clouds. Don't fight it. Just let it wash over you. Just let this image of clouds within clouds within clouds sink in. As we draw our network diagrams, if you open up any one cloud, there's usually multiple clouds in that. And if you open up any one of those clouds, there's multiple networks in that. I tried to give you some dramatic foreshadowing by saying networks talking to networks talking to networks, and networks within networks within networks. The internet is not one cloud. The internet is a conglomeration of networks owned by different companies that are all able to talk to each other because they agree voluntarily to use the same set of TCP/IP protocols. This is a pretty popular map of the internet. So this is a good place to end on when we're talking about WAN circuits and the internet, of course. Exam answer. the world's largest public WAN. Yeah, there's WAN circuits. I hope you'll email me any questions you have. We should have some time next week to chat a little bit about this, and I'll be happy to take your questions. But that's it for Chapter 10. See you soon.